Hello again. Alright, so we're going to continue with the endocrine system, and today we're going to talk about the anterior pituitary, continue with that, and focus on growth hormone and a little bit on MSH or melanocyte stimulating hormone. So if you remember, we've talked about the way the hypothalamus and the anterior pituitary are connected and how the hypothalamus releases stimulating and inhibiting hormones onto the anterior pituitary, causing the anterior pituitary then to release other hormones. And then those hormones go out into the blood and cause effects on their target organs. Okay, so let's focus on growth hormone. And you have growth hormone releasing hormone and growth hormone inhibiting hormone or factors, which will cause either the anterior pituitary to release or not release growth hormone. So if growth hormone is released, it's going to travel into the blood to its target, and it goes to all tissues really, but the main ones that we're going to talk about are the bone, the muscle, and the fat. Okay, and so if you have the appropriate amount of growth hormone, then you're going to have develop your normal adult height and stature. Okay, growth hormone also plays a role in some metabolic effects. Okay, so it does some things like with sugar regulation. So let's move forward. So what growth hormone does is it stimulates most cells, but especially it targets bone and skeletal muscle. All right, and it does this by promoting protein synthesis and also encouraging the use of fat as fuel. Okay, so you can convert fat to fuel. So if you haven't looked over cellular respiration in a while, you might want to go back and kind of look at that. Growth hormone is secreted throughout your life, but you're going to have obviously more of that going through adolescence and when you're growing, but you have to maintain things your entire life, so you're going to have growth hormone all your life. It's the most abundant of the pituitary hormones, so a lot of growth hormone is secreted throughout your lifetime. So this is a schematic showing you that feedback mechanism. It's negative feedback, and so this is what these little dotted lines are showing you. And so you have the hypothalamus, which will secrete either growth hormone releasing or inhibiting hormones. The inhibiting one's also known as somatostatin, causing the anterior pituitary to release growth hormone. And this has two effects, either indirect or direct. So the direct actions are your metabolic, you can call them your anti-insulin effects. And so the effect would be causing increased fat breakdown. So the target would be fat. The effect would be increasing fat breakdown and carbohydrate metabolism. So you can increase blood glucose by decreasing glucose uptake and increasing glycogen breakdown. All right, so those are going to be effects on the cells and the liver, and then so all your cells that can take up sugars, your liver, which plays a role in glycogen storage and release, and then your fat. Okay. In the indirect actions, these are your growth promoting actions, and this is going to work by targeting the liver and causing the liver and some other tissues to produce something called insulin-like growth factors, or IGFs. And these IGFs then go out to this bone and then other extraskeletal like muscle and cause growth. So in skeletal muscle or the bones, you're going to see an increased cartilage formation. Because you remember back to your bones, you lay down cartilage before you lay down on bone. So cartilage is the template. Extraskeletal, so those things outside the bones, increased protein synthesis, cell growth, and proliferation. So increased mitosis. So the feedback, if you have plenty of these IGFs, that's going to feed back negatively and say, okay, we don't need any more GHRH or GHIH and don't need any more growth hormone. Growth hormone itself, if you have plenty of growth hormone in the blood, it'll also feed back negatively and shut down the release of GHRH and GHIH. Okay? So we always talk about too much, too little. So hypersecretion, this is a case for both of those. Hypersecretion or too much in children leads to kind of an overgrowth of the whole skeletal system, and we call that gigantism. This is a 12-year-old boy, and he's already 6'5". Okay, too much growth hormone, so possibly a tumor in an adult. Both of these could be due to a tumor, but specifically thinking about something that may be causing too much growth hormone in an adult, we call that acromegaly, where there's too much growth hormone in the adult. Because remember, we get some, but there's just too much. And there are some parts of your body that will continue to grow, particularly your jaw and your hands. And so if you look at, this is Andre the Giant from Princess Bride, and if you'll notice, the size of his jaws and hands are really large, inordinately large compared to the rest of him. Even though he was already a big guy, he also has this large jaw and hands. And so over time, people with acromegaly tend to have heart failure. It takes a toll on the heart, and that's exactly what happened. I think he was in his 40s and died of a cardiac event, heart attack. So I want to point out this condition here, the gigantism. This is one of the things that they're looking for. So if you've always wondered, maybe you go to the doctor, and when you're little, and maybe you have children of your own, and you start to see they're graphing out your height and your weight on a growth chart, and maybe you were wondering why they were doing that. And so if you look at these growth charts, there's kind of an average range. Okay, so there's like the high numbers and the low numbers. And so as you're going in and taking yourself or your child in there, and they map this, what they're looking for is, are you falling in that normal range? If you're falling outside of that normal, even the outside kind of limits of normal tall and the outside limits of normal short, they're looking at that. And so if perhaps you're kind of falling outside that normal high range, that might be an indication of something going on, like gigantism. If you're falling below the normal range, you're really, really short compared to the normal range, perhaps it's dwarfism. So there's pituitary dwarfism, which is hyposecretion of growth hormone in children. So this is the guy that played Flitwick and some of the goblins, I believe, in Harry Potter. All right, so you can see this is pituitary dwarfism. And I just put this picture in here to show you just the varying amounts of height that people can have based on changes in growth hormone. So this would be a lady with a normal stature. This would be someone that would be considered very tall, or possibly giant. And then you have the someone who's very short. So this would be just an example of imbalances in growth hormone compared to normal. So again, this is why they're doing those growth charts, to see where are you falling compared to normal, and perhaps that's an indication that there's something they can do. Perhaps give you growth hormone to help you reach your normal stature. Perhaps see if there's something going on like a tumor, so what's causing that overproduction of growth hormone. So maybe they can stop it. So that's the purpose of these. One of the purposes of these charts. That's really all I'm going to talk about with growth hormone right now. The other hormone we want to talk about is MSH, which is melanocyte stimulating hormone. So if you go back to melanocytes, those are the cells that give your skin, the pigment in cells that give your skin color. So melanocytes make melanin, which gives your skin either a yellow pigment or a red pigment or a dark pigment, black pigment, brown pigment, kind of a Caucasian pink pigment. So whatever pigment your color is based on that melanin. We don't have a real understanding of why we have that in adults. We do in fetuses, in fetal development. There is a lot of melanocyte MSH being secreted by the pituitary, so it kind of regulates that melanin production and kind of establishes our ethnic color. But then after that, we don't know a whole lot about why we have it after that. There is a lot of research out there that shows it's really important in lower vertebrates. So if you're into comparative, you might want to go out and look at that. We will talk about this later on when we talk about Addison's disease. So there is a little bit of interesting information about MSH and Addison's disease. So we'll get to that later on in the semester. All right, so that's all I'm going to talk about now, and I'll see you in the next video. Thanks.